Hey guys, so rather than dealing with frustrating Google Meets and me cutting in and out, I'll make this video real quick, and I think it might, serve us a little better here. If at any point you have questions, please shoot me an email and we'll get those addressed. Okay, so our focus today, like I said yesterday in class, was to understand the calculator. All right, and the ability that gives us, it's just a big help. Okay, so this is the same worksheet from yesterday. I think we have a pretty good idea about what would be expected here, right? So when you have to first sketch this curve. All right, try to make it as symmetrical as you can. Label the mean. Label 1, 2, and 3 standard deviations to both the left and the right. Okay, and use these numbers that you're given. Use the 63.1 and the 4.8, and we kind of addressed that yesterday in class. Let's look at B here. Find the proportion of runners whose body weight is between 48.7 and 67.9. So I would recommend drawing this curve just so that I can maybe give you partial credit should you get something wrong. The mean's right there in the middle. All right, 48.7, you can kind of look to see where that was labeled, right? And it should be 3 standard deviations below, and then 67.9 is 1 standard deviation above. And that should have just been from you labeling the axis in part A. All right, so if we were to go here, you'd go 1, 2, 3, 1 above the mean, and we would shade this area in, right? And yesterday we worked with 68, 95, cutting them in half, the ins and outs of those 3 values. But for today, I just want to tell you that rather than doing that, you are perfectly able to, on your calculator, use menu 552. All right. And when you hit menu 552, it's going to ask you 4 things. It's going to ask you your bounds, your lower bound and your upper bound. It's going to ask you the mean and the standard deviation. So I'll just abbreviate a little bit, but lower bound, upper bound, it's going to give you the mean, standard deviation. So you have to interpret the boundaries, what the problem's asking you. And it's saying, okay, give us the proportion between these 2 values. So that means between 48.7, that would be the smaller of our 2 numbers, and 67.9. All right, the mean and the standard deviation are given to us in the problem. 63.1, 4.8. All right. So again, I'll pick up my calculator now, and it would be menu 552. It's going to ask you your lower bound. It's going to ask you your upper bound and your mean and your standard deviation. Once you enter those, hit OK, and then it's going to give you this output along with it, the answer, which is a decimal. What I would like you to do is show this. All right, show norm CDF. Show me the values that you entered, and then give me the answer, which is 83.99, which is about 84%. Okay? You don't have to show me it like this, but this would be your answer. Okay? We'll go down here. We'll try that again. So if you want, you draw the curve. Label the 2 values that I ask you to find. All right. If you want, you shade. But more importantly, I want you to hit menu 552. I want you to write norm CDF. And it's going to be 48.7, comma 72.7, and then the mean and the standard deviation. So that's what the output's going to look like from your calculator. So you're going to hit menu 552 and use those values. Use 48.7 as your lower bound because it's the smaller of the two numbers. 72.7, 63.1, and 4.8. Once you hit enter, you're going to get something like that looks just like what I wrote there from the calculator. Write that down, exactly how it looks, as well as writing down the answer, which is 0.9759. All right, you could certainly round that to 2 decimals, 3 decimals, that'd be fine. All right. Let's do another example here. All right, so yesterday we did these. We did this example with the math scores. Now, again, I think you draw the curve, you label the points. It says find the proportion. It would give you 2 values. Let's look at one where it doesn't give us 2 values. It says, for example, this one: find the proportion of scores that are less than 310. All right, so what I would do again is draw the curve, a rough sketch. All right, and then shade whatever it would be in this case. So 310, you would say, is right here. You would shade the values that are less than that, okay? And then you would pick up your calculator and hit menu 552. This time, your lower bound is going to be like a big number, all right? It's going to represent negative or positive infinity. So your lower bound should be negative 1,000. Your upper bound should be 310. The mean score here, I believe, was 494. And the standard deviation was 92. So that was just taken from the problem. The mean, the standard deviation. So 494, 92, and we should get 0.02275. All right, so a small number. Is it going to be slightly off from what we got by hand using the 68, the 95, and the 99.7 rule? Yeah, it could be, but just very, very, insignificantly. All right. Again, we always answer these questions as like about or approximately. So the small difference there that the calculator gives us is not a big deal at all. So let me show you again what to write. Norm CDF stands for normal distribution, CDF. And then you're going to put negative infinity, which we can just use a number like 1,000, or because it's negative infinity, we would use negative 1,000. 310. Excuse me, 310. $494.92. The answer I got was 0.0227. 0.0227. All right. If it was, let's just say it read, greater than. That's a greater than sign. Greater than 310. What numbers would change? Well, your lower bound would be 310. Your upper bound would be positive 1,000. All right. So again, you would do norm CDF, which is menu 552, and punch in those values. That's it. All right. Why or when do we absolutely need the calculator? Well, we would need it when these values would be something other than what would exactly fall 1, 2, or 3 standard deviations above or below the mean. So for example, if I go back up to the beginning of problem 2, and let's say we were to do something like this, right? This will be our last problem, guys, I promise. So 494 was our mean. And I'm going to label 1 above and 1 below. So this would be 402. This would be 586. So right now we know that 68% of the data falls between these two numbers. All right, using our 68, 95, and 99.7 rule. Well, what happens if I asked you a question? I said, all right, well, what proportion of runners were between 400, or I'm sorry, not runners. What proportion of students scored between 460 and let's say 531? So we want to know what proportion scored between 460. We could just round that to being right there, and 531. So we know it's less than 68, right? But at the same time, these are numbers that do not fall exactly 1, 2, or 3 standard deviations below or above the mean. So you would have to use the calculator. You would have to go norm CDF. You'd have your lower and upper bounds. You'd have your mean. And your standard deviation, right? So 552, enter the correct bounds. And you should get about 30%, 0.3004. So you could just round that or say approximately 30%, right? We wouldn't be able to do that without the calculator. Well, there is this other way, but it involves using a table and doing more work. So the calculator is certainly easier. So you need the calculator to do problems like that, but you can use it for all problems on this worksheet, okay? Hopefully this video helps. If you have questions, just shoot me an email, and maybe we can schedule like a smaller Google Meet. I don't know if it was the size of the Google Meet that was giving us an issue, but whatever it is. All right, guys. Let me know if you have questions. Sorry again, and hope this helps.